Here we need to rewrite this triple integral using spherical coordinates, because the solid under consideration here is above the cone, this cone, and inside the sphere. X square plus y square plus z square equals 16, and we know that x square plus y square plus z square is rho square. So this sphere is same as rho square equals 16, and rho is non-negative number, so rho is 4. Okay, so our solid lies inside this sphere, means rho has the bounds from 0 to 4. So we can describe the solid here. Rho is the collection of rho, theta and phi. Rho is in between 0 and 4 because of this sphere. Okay, and the next, and if we graph this sphere, let me graph here, and at least we are clear about rho part. Now we need to find the bounds for theta and phi. Okay, so here x, y and z. So we have this sphere, unit, pretty much standard sphere, center at 0, 0, 0 and radius 4. So 4, okay, it's a sphere, something like this. And that means if we look at the projection on xy plane from top, if we look from the top, then we'll see the middle part, pretty much a circle. Okay, so if we consider the projection on xy plane here, so we'll see a circle of radius 4. So for our theta, which is measured from positive x-axis, it goes all around the x-axis. That means 0 to 2 pi. So this is also clear now. Theta is from 0 to 2 pi. Okay, this our solid is not only this, we have something, but still if we look from the top, we get 0 to 2 pi. And we have to worry about finding phi, and if we read carefully, yes, is the solid region above the cone and inside the sphere. So inside the sphere and above this cone, g equals this non-negative number. I mean, square root of anything is always positive. It can be 0 though. So if we graph this cone, this is non-negative, means it will be above xy plane. Cone means something like here, something like here, I don't know. Okay, and this is not the exact, but similar to this. And we are considering this part on the top, that's above this cone, and inside the cone, because cone has here. So we are getting this region on the top, and this is the cone part. Okay, this is in fact 3D. So this is the solid we are considering. And this phi, now the problem with this phi is measured from the positive g-axis. So we need to find g up to this angle, because we don't go beyond this line. So this line from g-axis. Okay, so we have g-axis and we have a cone, let's say this, and we are looking for this angle as phi. So we need to solve this cone. Let's solve this cone and find this phi. And as soon as we have phi, we can easily rewrite in triple integral using spherical coordinates. And if we look at this closely, we are already done with rho and theta, and x is in fact rho sine phi cosine theta, just the transformation. Y is rho sine phi sine theta, and z is rho cosine phi times dv is this whole junk, rho square sine phi, d rho, d theta, d phi. So the issue here is to figure out the bounds for phi, okay, here. So for that, let's look at this cone. So we have the cone g equals root 3x squared plus 3y squared, and we'll go above that. If we square both sides, we get g squared equals 3x squared plus 3y squared. So we are trying to find this angle phi, okay? Just remember that part. And we know x squared plus y squared plus g squared is rho squared. So let's add 3g squared both sides. Then we have 4g squared equals, we can factor 3 out, that leaves x squared plus y squared plus g squared, which is rho squared, okay? And we know that g is equal to here rho cosine phi. So this is 4 rho cosine phi squared. So rho squared cosine squared phi equals 3 rho squared. Now rho squared, rho is a positive number, non-negative number, so we can cancel from both sides. Then cosine squared phi is 3 over 4. Take square root both sides. Cosine phi is 3 root 3 over 2 plus minus, but phi is always in between 0 and pi, and it will be a positive angle. So as we saw earlier, we want to take the smallest angle because our cone was like this, and above this clearly it should be not even 90 degree. I mean, this would have been 90 degree, but it's less than 90. So we just take positive here, and we know that cosine pi over 6, cosine 30 is root 3 over 2. So p is in fact pi over 6. Okay, I mean that's the whole thing here. So this solid, now we can say this is pi over 6. Pi over 6. Okay, and we are not supposed to evaluate, which can be done, but it's just tedious, and this is it.